All right, guys, this is example A, and you've had a couple minutes hopefully to think about it. I want you guys to think about the objective of this section and the title, because it's really going to drive your thought process here. Our job is to solve quadratic equations, okay, specifically by factoring, but that part will come in a minute. But I'm focused on this quadratic, and it's probably a little bit crazy. You might not have seen equations like this before. However, this quadratic lies in an exponent. So what type of exponent, when any number is raised to it, will always equal 1? And think about it. If my exponent is 0, anything to the 0 power is 1. So that is what's going to drive this whole entire problem. So I come down here and I just set the entire exponent equal to 0, okay? The 4 doesn't matter. It's just there. It could be any number. So now that we've set this up, we could solve this quadratic using any method that you guys learned in Algebra 2 or in Algebra 1. But this is specifically getting you guys to think about factoring, okay? So I factor this using a method called the AC method, or it's called the surefire method. But what this does is you multiply the first term, your leading coefficient, and that constant, okay, or the A and the C term in the quadratic expression. So if you do that, you end up with negative 12. So if I were to think about two numbers that multiply to be negative 12, that add up to my B term, which in this case is 1, then my two numbers would be 4 and negative 3. Okay, and now what this method does is I take those two numbers that I just came up with and I rewrite my quadratic equation. I expand it. So instead of it being 3 terms, it's now going to be 4 terms. And I use those to rewrite that B term. Okay, I don't know why this 0 turned pink, but it's okay. There we go. So once I have expanded this quadratic, now what I can do is I can factor it by parts, okay? And if I look at this first part, think about what is the greatest common factor I could take out of those two terms. I could take out 2x, leaving me with x plus 2, okay? And this is also referred to as factoring by grouping. Then if I group the second two terms, think about what you can do. And sometimes that second group, sometimes you'll see teachers put parentheses specifically around those last two, which kind of helps the student because what you're doing is that minus sign just kind of carries straight down, so you never really miss it. But what I want you to also think about is, well, what if that set of parentheses was really here, right? What is the greatest common factor? And anytime that leading coefficient in that group is negative, you're always going to take a negative out. So I'm taking out a negative 3. I cannot take an x out because 6 doesn't have an x. And I'm left with x plus 2. Okay? Now, when you factor by grouping like this, each group you're going to notice has something in common, and your leftovers that are in these parentheses are the same. Okay, so we're still kind of factoring by taking out a greatest common factor. So each side has an x plus 2. That's that common factor. So if we were to take that x plus 2 away, this first term would be left with a 2x. The second one would be just a negative 3. And then there's that common factor of an x plus 2. And we have factored. Now, this type of factoring really is only useful or necessary when our leading coefficient is higher than 1. Okay, so it was a 2. I couldn't take the 2 out, so I had to come up with some other method. Now, some of you guys might be able to look at this and go right from here to here because your brain can just separate that, and that's perfect. You can do that, absolutely. ACE just requires you to be able to factor and show your work. That's the really cool part about it. So the objective here, let's go back to the question, is to solve this. So I still have a little bit of work to do. If I set this first factor equal to 0, my solution would be x equals 3 over 2. And if I solve the second one, my solution would be x equals negative 2. So x could be either one of these answers and that expression would equal 1.